Hello, this video goes over Topic 6 review looking at lessons 6-3 and 6-4. So this is just making comparative inferences, and it focused on box plots and dot plots. So box plots and dot plots are common ways to display data gathered from samples of populations. Using these data displays makes it easier to visually compare sets of data and make inferences. Statistical measures such as mean, median, mode, MAD, interquartile range, which is IQR, and range can be used to draw inferences about comparing populations. I'm going to look at the example that's dealing with the box plots first. So there it is. So with this box plot, when you look at a box plot, you need to read kind of what it is about, and then you need to look at the labels when you have a double box plot. So the box plot shows how long it took students in Ms. Tom's 2 math classes to complete their math homework last night, and it's told us to use the median. So on a box plot, it's important to be able to identify the median. The median is the line at the box. So we see first period and second period here, and we can see with that line, it's very visual for the median that it is 30 minutes for first period and it is 35 minutes for second period. So it looks like second period it tended to take a little bit longer on their homework. Now looking at the practice of number 1, the 2 data sets show the number of days the team members trained before a 5K race and what inference can be drawn by comparing the medians. So looking at the medians here, I'm going to highlight them. That's Team A's median, Team B's median. So we can say, comparing the medians, that Team B trained for longer days. It looks like Team A was around 20, and this looks like about 24. So we could say about 4 more days. I'm just going to write Team B trained more days. What inference can be drawn by comparing the interquartile ranges? So looking at the interquartile ranges, we're looking at the box. So it would be this number minus this number if we actually calculate it. But looking at the size of the boxes, these line up perfectly over here. I can tell that Team A's the interquartile range is larger. So this box shows 50% of the data. So it shows the inner 50% of the data. So I can say that Team B consistently trained for more days, or I could say the reverse, that Team A, it has less consistency or more spread out data. I'm just going to write these down. Team B trained more days based off of the median. And Team B consistently trained more days based off of the IQR and the median together. Okay, let's look at the example that's dealing with the dot plots. So with dot plots, you're given all the data values. So this means that you can calculate any measure of center and any measure of variability you want to. On box plots, you aren't given all the data, so you only can calculate medians because they're shown on the box plots, ranges, and interquartile ranges. You can't see all the other things. So what can we infer by these 2 box plots? Well, looking at this is baseball teams, and it's their first 8 games of the season. So it's how many runs they scored, and it's labeled on each of them. The nice thing that they did is they used the same scale, so you can very easily kind of see what's going on here. And we could say the Blue Jays are a higher scoring team. You kind of see the mode here. There's the mode for the Blue Jays, and then the Tigers, that mode it has two modes, 2 and 4. They're a little bit lower. You can also see that this data is from 2 to 7, where this data is from 1 to 7, and it seems a little more clustered on the lower end. So that's another thing that we can visually see. Looking at the example, the dot plots show how long it would take students in 2 science classes to finish their science homework, and we're supposed to make an inference. So one thing that we can do is we can find the mean. When you find the mean, you would add up all these data points and then divide by how many numbers that we have. You can also find a median, which is the middle number for each, and then you could compare those. When I visually compare their ranges, since they use the same scale, the ranges are fairly similar. Second period has a little bit farther of a range, and but overall, it looks like we're seeing kind of consistent shapes. So it seems that it's spread out in similar ways. So the best way would be to look at the mean and the median to get some details here. So the mean ends up being 38.75 for first period, and it ends up being 35 for second period. So how I did that is I added up all those numbers, 1, 2, and then I divided by how many numbers I had. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we had 775 altogether. Divided by 20 would give us that mean. And for the second one, we had 700, and it's still 20 people, and you would divide that by the 20 people, and you'll get 35. So that is how I got both of those means. And now I'm going to show you how I can get the median. So it's 20 sets of data. So the median would split that in half, and I'm going to find the 10th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between the 10th and 11th one would split the data in half. So it looks like my median is 35. And down here, still 20 people. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between the 10 and 11, that median is 30. So looking at comparing our medians and comparing our means, we actually see a similar comparison that first period took a little bit longer on their homework.